So in problem 2.2, and what do you expect, we were looking at area models for situations in which the outcomes are not equally likely. So here we have a situation that describes that. In this floor plan, the character will start at the starting point, come to a fork in the road, and have two paths that are equally likely to be selected. So initially, there is an equally likely chance of those two paths. If path 1 is followed, there's a second fork in the road, and there are three paths. So continuing our numbering, we've got path 3, path 4, and path 5. Path 3 ends up in a cave, 4 ends up in a cave, and 5 ends up in a cave. So we go back to the first fork and follow path 2. Path 2 comes to this fork in the road, and there are two paths that are possible, equally likely to be selected. So we've got path 6 and path 7. Path 6 leads to a cave. Path 7, however, comes to another fork in the road, and there are two paths, so I'll label those path 8 and path 9. And now we'll look at how to set this up in an area model format. Okay, so now we're going to take our rectangular area and divide it up into sections to represent the floor plan over here. First thing is we come to a fork in the road, and there are two paths that are equally likely to be selected. So we're going to divide our area of our rectangle into two sections using the vertical one for the first fork. Okay, spending a little more time to be careful on paper. On here, I'm just going to try to do this in one motion. So I'm making one section, labeling it path 1, path 2. For our second situation, if path 1 is taken, we come to a fork in the road, and there are three paths to be equally likely selected from. So we're going to take just path number 1 and divide that to represent the second fork. And there are three sections, so we're going to try to divide those into thirds, and it's just that first path. So we're representing path 3, 4, and 5. Path 1, 3 leads directly to cave B. Path 1, 4 leads directly to cave B also. Path 1, 5 leads to cave A. So we now have our path 1 finished, and we can go back to the first fork in the road and now focus on what if path 2 was taken. Following path 2, we come to a second fork in the road, which I used my horizontal division to do, and there are two paths that are equally likely to be selected. So that second path now has two equally likely paths to be selected, path 6 and path 7. If path 6 is taken, that's following path 2 and then 6, it leads directly to cave A. If path 2, 7 is taken, then we come to a third fork in the road, down here, and now we need to label, and I'm going to choose to do this again on the vertical side, the third fork. There are two paths, so that region gets divided into half, representing path 8 and 9. So from the beginning, this first section is path 2, then 7, then 8, and it leads to cave A. Below that we have path 2, 7, and 9, and it leads to cave B. We're now going to shade in all of the paths that represent leading to cave A. So the next step is looking at, do we have equal sized pieces? And we obviously don't on this one. So now our task is to divide the overall rectangular region, the original rectangle, into equal sized pieces. So if we go back to the beginning, On the top rectangular piece here, this path number 1, this was divided into 3 equal-sized regions. So we need to make sure that this bottom path is also divided into those same 3 equal regions. What that looks like is simply connecting those lines all the way through to the other side. Then we have this middle region here that has a further division in there. So if you remember back here, this side here the second path was divided in half. So we need to make sure that this top section is also divided in half. Continuing that forward. Okay, so now looking at this section down here, which was 1/4 of the original rectangle, this has been divided in half horizontally. So we've got 2 halves here to this 1/4 size piece. So all of the other quarters need to be divided in half. In the bottom part, that simply looks like drawing that line, continuing all the way across to the other side. But remembering that if this bottom half was cut in half horizontally, this top half needs to be cut in half horizontally. So now going back to that middle section, this middle third of path 1 was cut in half. So each of these third-sized pieces needs to be cut in half, going all the way through from one side to the next. Okay. So again, thinking about all the fractional parts, vertically, this section was divided in half, and then each of those halves were divided in half. That creates 4 rows. Horizontally, we were originally divided into thirds, and another section was divided in half, so we've got thirds and halves making a total of 6. That requires 6 columns going across. So now we have our area divided up into equal-sized pieces. There are 4 rows, 6 columns, making 24 equal-sized pieces. So now looking at our total area, the probability of the character ending up in cave A. There are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of the 24 sections that are shaded in representing cave A. 24. And the probability then of the character ending up in cave B. And we're going to count to make sure. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections out of the 24 that are representing cave B. And then just to verify, making sure that our 13 and our 11 total 24. So this is the probability of ending up in cave A or cave B using an area model. In our final example, we have another floor plan. So again, analyzing this, fork in the road that has 2 paths, labeling those 1 and 2. If path 1 is taken, there's another fork in the road with 2 paths, so we've got 3 and 4. If path 3 is taken, there's another fork in the road leading us to path 5 and 6. Both of those lead to a cave. We go back and check path 4, that leads to a cave. So we go back to the first fork and follow path 2. Path 2 has a fork in the road leading us to paths 7 and 8. If path 7 is taken, it leads to a cave. If path 8 is taken, it has another fork in the road leading us to paths 9 and 10. And both of those lead to a cave. So now we're ready to make our area model. Okay, so now looking at our area model, starting with the first fork. So again, I'm going to divide this section here. And there are 2 equal-sized, or 2 equally likely outcomes, so path 1 and 2. So that divides our region in 2. If path 1 is taken, there is another fork in the road, and at that fork there are 2 paths that are equally likely to be selected from. So our second fork is 2 equal sized pieces, about there. So path 3 and 4. If path 3 is taken, there's another fork in the road for paths leading to paths 5 and 6. And I'm going to do my third fork over on the side. So paths 5 and 6, but divided here. So this top region is representing path 3, or path 1, path 3, path 5, and leads to cave B. The lower region, or the lower section, is path 1, path 3, path 6, and that leads to cave A. So now looking at our area model, or excuse me, our floor plan, we now have to go back to right here, and path 4 is the second option, and it goes directly to cave A. So path 1, 4 is cave A. So we are now finished with everything that occurred as a result of heading to the first path. So back here at the first fork, we are now taking path 2, and we come to a second fork in the road. Our second fork is our horizontal labeling, but it's down in this section down here. So I'm going to divide this region in half to represent those two paths, number 7 and 8. If path 7 is taken, it leads to cave A. So a 2-7 combination goes to cave A. If path 8 is taken, however, there comes the last fork in the road leading to paths 9 and 10. So just like I did on the first one, my third fork I'm going to represent down here. And there are 2 equally likely outcomes of path 9 and 10, dividing this region in half. So if paths 2, 8, and 9 are taken, the character ends up in cave A. And if path 2, 8, and 10 is taken, the character ends up in cave B. So just like last time, the next step is to shade in all the caves, or all the path combinations that end up in cave A. And it doesn't have to be pretty, but it's very important that these get marked, because when we start further dividing our region, sometimes we get kind of lost in which sections we're representing A and which ones for B. Okay, so the last thing is dividing the region, the area fully into equal sized pieces, because we don't have equal sized pieces, and with probability, just like with fractions, we need to have equal sized pieces. So this one's a little bit easier than the last one. We simply need to continue these lines going all the way through the shape. And then we can verify the vertical measure was divided in half, and then part of that was divided in half again, so the second part needs to be divided in half again. Horizontally, this section here was divided in half both times, so that's the only division. Okay, I kind of lost the end of that page, so I have to start a new one here. So my area model looks a little bit different than it did a second ago, but I just redid another one real quick. And now looking at the probabilities. The probability of ending up in cave A, there's 1, 2, 3, 4, 5, 6 sections out of 8, and the probability of ending up in cave B is those remaining 2 out of 8. So the probability of the character ending up in cave A is 6/8, and the probability of the character ending up in cave B is 2/8.